A wave relation problem. What is the wavelength in meters if the frequency is 5 hertz and the wave speed 10 meters per second? And there's 5 choices. We'll use the inquiry arc framework to analyze this question, and that consists first of looking at the inquire stage. Inquire. What is the wavelength? So I write down, I need to know my wavelength. That's the question mark. This is what I'm looking for. So I write down symbolic form, the shorthand notation. That's going to help me figure out what the formula is. Then I'm given, again in symbolic form, look, F equals 5 hertz, and V, the velocity, 10 meters per second. Now I can see what the principle is because I see a wavelength, I see an F, I see a V. That jars my memory. Then I'm going to be using this formula because that has all 3 of them. He's given me 2. He wants me to find the third. So we apply by plugging in the formula. We have 10 for the V. The lambda is to be determined. 5 here. And what number times 5 is 10? I can see that's 2. Or I can divide both sides of this equation by 5. That frees up the lambda on this side. 5 divided by 5 is 1, and 10 divided by the 5 is 2. 2 meters. Well, let's reflect on this. Does that make sense? Well, let's look at a visual representation. In class, we saw the ideal surfer, and the ideal surfer here is on one of the crests, and we have a distance from one crest to the other, and this pattern or this wave or this water is going to move by in an ideal fashion to the right. If the wavelength is 2 meters and the frequency is 5 going by per second, then I'll be 5 times 2 meters down the road, 10 meters per second. So that checks out. The answer is here, 2. In other words, I looked at this problem from a different angle in the reflection stage. I looked at my answer, the 2 meters. I looked at the 5 hertz, which was given, and the 10 meters per second. And from the little ideal surfing picture, these numbers are all consistent. 2 times 5 is 10. So I, with confidence, pick